Ladies and gentlemen, welcome to my tutorial videos on Unreal Engine. On today's tutorial, we will be building a user interface for age verification when the user first launches your game. We will also learn how to save this value so you only have to ask this once. Remember, Google will not accept your game without it, so this is an essential part of a game that first-time devs usually forget. I love upskilling myself learning from the internet. So now that it's my time to pass some knowledge, I will do it in a way that I find most effective. And that is to always start with showing the finished product. This is the final look of our widget. It is responsive, which means that it will easily fit any device width and height. You can use it for your mobile phones or you can use it for tablets. It will fit on any device. Since you are here, I'm assuming that you do know the basics of game dev on Unreal Engine. No one starts their journey with UI, so I'm going to skip showing around the dev environment and jump straight to it. Hit Ctrl Space to bring up your game's files. It's free to be organized, so create a new directory where you will be storing all your widgets. Inside your widgets folder, create a new blueprint of class userWidget. Now, because we are civilized people, we will use the standard way of naming our files wb_agegate. Open this file. In this blueprint file, we will design and create the functionality for our UI. From our palette, go ahead and drop the canvas panel. You can drag it from the corner to adjust as per the target device. We are designing for mobile phones in portrait mode primarily, so we will adjust to that. Next, we can add a little bit of background blur from the palette, and then I like to add the overlay. Background blur by definition is easy to figure out. Overlay is also exactly what it is named. Overlays are used to stack multiple child widgets on top of each other in the same area. Think of them like layers. We don't need to use it now, but it can be helpful when scaling. Let's create a border as a child of this overlay, and then nest a vertical box, which aligns all of its children vertically. We need a couple of text boxes. This is visually bothering me, so let's just make it full screen by adding the anchor points of our background. We can now head on over to our border and make the alpha value of the tint to 0.1. If by any chance your system is glitching and you can't find these values, just compile your project and it should be updated. Let me quickly rename the text boxes. We will rename them as header, description, and note. Now we need some space here, and there is something called the spacer in our palette. We will use that, and then we want input from the user. So for this purpose, we will be using a spin box. I feel it is better to use rather than an input text box. Spin boxes accepts only numeric values, so we don't need to validate user input. From our hierarchy, we can duplicate our spacer and reposition it. And then finally, we need a button and a text on the button to close and save this data. Let's make sure everything is renamed to correctly identify them in future. And make finishing touches by adding one more spacer and a text box for acknowledging privacy policy and terms of use. From our hierarchy, select background blur and scroll down in the details menu to set the blur strength to 5. This will pixelate our background. With overlay selected, I like to give it a small padding of 4 on the sides and 2 on top and bottom, just so it's not bleeding edge. Border is a child of overlay, so whatever padding we give to it, it will be with respect to overlay. Let's go bonkers here and give it a padding of 150 on the sides and 200 on top and bottom. We can adjust our screen size to see that it will always obey the 150 and 200 rule of padding. Let's head on over to our widgets. All the elements in our hierarchy are called widgets. Add a padding of 20-10. That's 20 on the sides and 10 on top and bottom. For our header, let's give a size of 60. That's That's too big, so let's go for 50 and center it using justification. For our description, let's justify it. And as you can see that it is going outside of our bonds. For this purpose, we will use auto wrap text and we can specify a size of 500 to it. Let's increase our font size to 24. And now you can see that irrespective of our device width, the text will be wrapped at 500 always. But 500 is still on the lower side of the spectrum. So let's change it to 750. We can repeat the steps for our note, font size as well, and justify it. We can also change the color of our text using the color picker. This highlights this note more. Next up, let's use our spacer. We only need to change the value of Y and keep it at 75. We can repeat this for all of our spacers. Finally, our acknowledgement. Let's stay uniform and apply the same style to it. That is font size of 24 and justify it and auto wrap it. Coming to our spin box, we don't need this full width. So let's fix it to content wrap, but it's still small. So we can add padding inside it by adding values to text padding inside style. Well, there, nothing happened. Sometimes Unreal Editor glitches out, but once you compile, the changes take effect. Let's give it a minimum value of 7, so that's the lowest age a person can be to play our game. Increase the font size and move over to our button. Staying uniform, let's change the button from full width to content wrap and add a bit of color. But nothing changed, even after compiling. That's because we were editing the Forward section. Let's go to the normal section and change it from there. Now you see the changes take effect now. We can also add an outline, reducing the width of the outline. We can also add sounds to our button clicks for hovering and pressing it. The padding on the top is for the padding outside the button, but we want to add the padding inside the button. So that can be found in the normal padding section of style. We will stay uniform and give it a padding of 20, 25, 10. That's the same for our spin box. And let's go to our text box and change the font to 42 so it stays uniform. We can also add corner radii in the outline settings, and this will make the button more rounded and not sharp. Unreal Engine makes it way too easy to make changes in our hierarchy. We forgot to add a scale box, so our elements will scale as per the device width and height. We want to wrap our vertical box in a scale box, so just right click on it and wrap it with a scale box. And now you can see the power of scale box. Let's add a padding of 20 to our scale box so nothing really comes outside of it. But as we can see, sometimes the vertical box is going outside the bounds of the scale box. There isn't really a setting in our stretch settings that can fix this. I told you the editor glitches out sometimes, so just compile the project again and it will re-render it. Nicely done. The designing part is now over. Now we move on to the fun part. At least it's fun for me. This video deals with coding and blueprints, so if you are looking for C++, leave a like and upload it next. Also consider subscribing so you don't miss my channel. We are going to have loads of tutorials, especially starting with UI. Click on the Graph tab to go to the graph editing mode. We don't need these events here, so you can delete it. You can always bring them back. Head back over to our designer, click on our button and scroll down to events. We are looking for the onClicked event. It's usually the first one. Now we need local variables here, and these values live inside this blueprint. We need a boolean value that asks if the user is an underage user and an integer value called age entered. SP age is our spin box. Drag that in. Now we will set our local variable integer with the value of SP age. So drag our age entered. We need to set the value, connect the nodes, and drag the pin from SPH. Oh, what's that? It's not working because this is our object reference and we need to connect the value of this object to our integer. Get value is the node, and once as you can see, now we can connect the value node to our integer. It's a float variable, so Unreal Engine will automatically truncate the float with integer. We can align them by selecting all the nodes and pressing Q. Now we need the branch node, which returns true and false. For our condition, we will check whether the age entered is greater than or equal to 13. That is the standard guidelines for classifying underage users. We will set the boolean value over here. For true, we want to check the underage user, and for false, we will uncheck it. Let's quickly recap. On pressing our button, we will fetch the value from our spin box. We will assign this value to our local variable of age entered. We will check whether it's greater than or equal to 13, and depending on that, we will set our boolean to true or false. It is time to save our data. Head back to our content drawer. Let's create a new directory for data called data. Inside this folder, we want to create a new blueprint class of subclass type SafeGame. Let's rename this BP_SafeGame. In this class, we will store variables of everything that needs to be saved. Right now, we have two local variables from our widget blueprint, so we will make two variables of the same type to match it over here. Giving it a different name will help. I like to add a suffix of _saved for all variables that are inside our SafeGame. Make sure to compile this file. The save load functionality is one of the most widely used repetitive nodes in our project, so it makes sense to create a function that we can call to do that. Create a new folder called functions and add a blueprint function library. All functions of this file can be used in any blueprint in our entire project. Let's call this function SavedGameData. From our SavedGameData, we need to add this does_SaveGameExist node and compile the project so you can add an input to your function. For the input, we will have our slot name. This is the input that we would give whenever we call this function. This is of type string, and attach the slot name pin to our does_SaveGameExist pin. From here, extend a branch node, and the return value of does_SaveGameExist will be the condition of our branch. For true, we want to load game from slot, and after this we will cast to our BP SafeGame. The return value of load game from slot goes to the object of our cast to SafeGame. Now we have our SafeGame reference, so we'll promote this to a variable in our SafeGame file, and we will call this SafeGame reference, SafeGame ref. We want to return this SafeGame reference whenever we call this function in other blueprints. So let's add an output to our function. We will call this SafeGame ref, and this will be of type BP SafeGame. Not the SafeGame, our SafeGame that we created, the object reference. Now let's fetch our local variable and connect these pins. From our false node, we want to create a SafeGame object. The SafeGame class over here will be our BP SafeGame, and this returns our SafeGame reference. But we don't want to promote that to variable. We already have a local variable, and we will just connect that pin. over here, and we will return, and from here we will go to the output node. This is our safe load functionality. Let's make sure our slot name is connected to our load game from slot. So let's add a reroute node. Let's add a reroute node. So it's neat and tidy. We can add one more over here and connect it. So the slot name that we provide in our function will be used for does save game exist and load game from slot as well. You can leave user index as 0. You usually use it if you have multiple players in your game. Okay, there is an error over here. We are supposed to cast to BP save game, not save game. So let's just fix that. Perfect. Let's connect our nodes. And now we will compile our project. Oh, oops. This is not working because our save game reference that we promoted was of save game, not BP save game. So let's just quickly refresh that. We will make a new variable and name it save game reference, after deleting the old one, of course. Perfect. Let's compile our project. It should compile successfully. Now let's finish editing our graph of our widget. The good thing about a BP function library is that it is accessible in all of our files. So I can just type in the function name, saved game data, and there it is. It is asking for slot name and returning the object reference just as we designed it. I am going to give it a slot name. Let's give it agegate1 and connect both the pins. We are also going to promote this value to a variable because we are going to be needing it in our flow later on. I'm going to give it a different name to avoid confusion. We have seen what happens when you give it a similar name. Now we just have to set our values in BP save game from our local variables. First the underage user boolean variable, followed by the age entered integer variable. Now we are passing both of our local variables to our save game file, and now we have save game to slot. This is so our data is saved. If you don't call this node, then your data won't be saved. Make sure that the target is our save game object. Let me quickly rearrange it so that it's just neat and tidy. For testing purpose, we can type in the slot name directly, but a more efficient way of doing it is to store the slot name in a variable. This is good practice. If you decide to change your slot name later on, it will change throughout your blueprint. So we have a slot name of type string. Once you compile, you can give it a default value, and over here I'm giving it the value of agegate1. Now I'm going to connect this local variable to our saved game data. Just making sure, yeah, and to our save game to slot. Let's compile our project. All that is left now is to print this widget on screen. For this, we will go to our level that will first load when the game is launched. Open the level blueprint. Interesting. Event begin play should already be here, but no worries. We can create this event again. I like to create a sequence here. Otherwise, the flow of the program becomes really long. So in sequence, first then 0 pin gets executed, and then 1, and then you can add more and more pins. From then 0, we have the create widget node, and class is our widget blueprint agegate. And from here, we are just going to add it to the viewport. The target should be the return value. Compile it and let's test it out. And there you have it. The widget is appearing as designed, but right now there is no functionality on it. We can adjust our age, but that is it. Let's head back to our widget blueprint. After save game to slot, we are going to execute the remove from parent node. And the target is widget, as we can see, and let's compile it. Now when you execute it and press continue, the widget disappears. Well, it is working now, but we can still control our player and camera. Firstly, we need to disable our clicks and touches outside our age gate box. For this, let's head back to our widget designer and we will wrap our overlay with a button. Now our entire canvas will be a button. Let's call this button BG or something. It's not really important. You can leave it as it is because this is going to be a disabled button. From the details menu, let's remove the padding, and in styles, we will make it transparent on normal, hovered, pressed, disabled, everything. There should be no chance of it to appear on our screen. We can just edit the alpha values, that's for transparency. Let's even remove the foreground color. I'm just making everything transparent. Let's also remove the normal padding, pressed padding, everything. And in interaction, we want to uncheck is focusable. Let's make sure that this didn't break our design. And perfect. We didn't break our existing design. Now to disable our control of the camera and the player. Let's head back to our widget blueprint one last time. And over here, we are calling an event called event construct. This event executes every time our widget is created. Once this widget has been created, we will call a node, and that is called set input mode UI only. Here we need to pass values of our player controller. We can do that by calling the function getPlayerController. The return value will be passed on to the player controller. In widget to focus will be a reference to itself, so we can call self, and in mouse lock mode will tell you if you want to lock your cursor within the bounds of the widget or set it free. We will let it be free. And flush input is there to clear out any button presses that are there in the buffer so you don't accidentally press a button. Consider enabling it for your project. Let's compile and run, and now we don't have control of our camera and player. But wait, how does Unreal know when to resume control? Let's hit continue and we are still stuck in UI mode. So we want to give control back to the user once they press the continue button. So on-clicked event of our button, at the very end, after removing it from parent, we will set input mode to game only, and we just need to pass the controller value. Now let's test it out. Okay, perfect. This is working as we expect it to work. Final step of the process is that this is going to be a one-time thing. So this can be achieved in our level blueprint. Right before we create our widget, we need to check something. We will call our saved game data function and we need to create a local variable for our slot name of type string. Let's compile it and give it the same name, AgeGate1. From the reference of our save game, we are going to fetch our user age saved, and if it is less than equal to 7, we will create this widget. 7 is the minimum value, so you can definitely save 0 as the default value when we were creating that variable. So let's add a branch, and that's the condition. So for true, we are going to create our widget. For false, we don't need to do anything. Let me quickly rearrange everything. We can add comments over here for future references. Trust me, you are going to forget this in the future, so it's better to comment everything. It's good practice. Now when we run the game, the widget doesn't appear because it has the value stored. We can rename our slot name to verify if the widget isn't dead entirely. So let's head back to our variable in our level blueprint, and from the details menu, let's change the slot name to AgeGate2, and let's test now, and we can see that the widget is still working. We can now give some finishing touches, add some more tint as per your choice. I'm finding this a bit too transparent, so I'm adding more tint to it. Now let's run our project, and that's much better. Let's make sure that it is responsive, and this is our finished look of our UI element of our AgeGate. It works as expected on all device widths and height. Thanks for sticking around. I'm not exactly a natural public speaker, so making these videos is me way outside my comfort zone. If you enjoyed my style of teaching, hit like so it reaches more people. And if you want to keep me motivated, consider subscribing to my channel, and my Patreon starts at just $1. That's all for today. Go make something cool now.